Hello everyone and welcome back GKCS. Today again we'll be discussing a very interesting problem. So we'll be talking about delivery system to be precise. Now you could be considering Swiggy delivery partners or Zomato, Amazon, any delivery partners. We'll be especially focusing on how can the delivery happen. So that will be our focus point today. We can first talk about the requirements in detail. First will be matching. Basically, we are considering the case where the restaurant has already accepted the order and now we have to match a delivery partner, and then we have to do the tracking of the delivery partner. So these two are the major things that we will be doing today, right?
Yes. In matching, we are going to have some things to consider. The most important is how much time is it going to take for the delivery partner to get food from the restaurant to your house. How high is the rating of this delivery partner? If they are high rated, then maybe they should get more deliveries in a day. And another thing which Kirti actually brought up is the sense of fairness, or that the delivery partners don't get too exhausted. If you have a person who's already made 10 deliveries a day, then everybody else is maybe sitting. So you're not utilizing the resources in the best way possible.
So when we do matching, we will essentially be considering these factors. Time seems like the most obvious one. Obviously, the time should be very less, but then these are also very important to consider, like for fairness and tracking was also a very interesting problem, because here, like if you have used Swiggy, Zomato, you must have seen that we can see the delivery partner approaching us, and you can also see that which route are they using and how much time they are going to take, and we can actually see them moving, right? So how does that happen, and how does the communication happen will also be an interesting thing to solve.
Yeah.
Yes. So of course, yes. So we have basically a person who has placed the order. So our delivery partner has to basically go to person's location, and then there are basically restaurants, right? So there are restaurants or restaurant owners, you can think of it like one entity, and then of course there are basically delivery partners, right?
Yeah.
So if we start from assigning the delivery partner, basically our restaurants are the one who are going to be like accepting the request, and that is where our whole assignment is going to start, correct? So restaurant is where it is starting, our request is going to start, and there is obviously going to be a service. So what do you want to call it, like delivery matching service?
Yeah, we can call it
delivery
delivery
management service. Yeah, cool. So the request is going to go from the restaurant to the delivery management service, right? That so and so request has been accepted, and now you have to manage the delivery, and then from here we have to take care of the rest of the things. Does that make sense?
Yeah. Just to clarify, this management service can have many things to a delivery. It can be ETA, right? How much time is it going to take for the delivery partner to reach your house? That is also something that Swiggy and Zomato show. So,
Correct.
and also it shows you a route. It shows you which roads they are taking and coming. 99% of the time they don't use it, but whatever. It's a nice blue line that you can enjoy. But in reality, I mean, all this is calculated, but we are not going to be looking at it just now because it can get very complex. We are looking at a very specific part, which is just tracking, not routing, right? Not estimation. We are just looking at tracking a delivery partner.
Correct. So since we have to manage the delivery partners, first of all, I think we should be talking about how we are storing the delivery partners and how many delivery partners are there, like a bit of capacity estimation as well. What do you think?
Yeah. One concern that I would have here is how many people do we need to match with? And would it make sense to cache them, or are we going to fire SQL queries? What's that going to look like?
Correct. So quick capacity estimation. So how many, like if we consider a particular city, right? So how many riders are going to be there in a particular city, and how many rough number of requests are we going to get?
Let's say per day in Mumbai, we get 1 million deliveries, which is a lot, like 1 in 20 people order. So that's insane. 5%. So 1 million deliveries. That's just one city. Yeah. So and now we know that there. Okay, if you want 1 million deliveries, I think at most a person can deliver in a day is like 10
Yes.
deliveries.
Yes. Yeah.
So
yeah.
that would be I would say 1 lakh deliveries. Sorry, 1 lakh riders in the city.
Okay. So there are 1 lakh riders per city. I'm making 10 deliveries in a day, so 1 million deliveries. All
Yeah.
right. And how are we storing these riders? So we'll obviously be storing per city riders, right? That does make sense,
Yeah, yeah, I think that makes a lot of sense. You can have it per
right?
city, some location wise.
Yes. So let's discuss how are we going to store these 1 lakh riders, first of all, right? Uh, per city database, if we are considering. So the common query that we are going to get, first of all, is the location of the drivers and like who are the drivers near this location, correct? That is the common query that we are going to get from this
Yeah.
database. Uh, now there are possible DBs that we can consider. We agree that the schema is not going to change. So SQL DB could have been an option, but the query is going to be very complex if you use SQL DB. So that doesn't make a lot of sense. Cassandra would have been a good option, or any columnar database could have been a good option. But also here, because we have to go like according to the geolocation, what about something like quadtrees, right? That does make sense to use geospatial databases over here. What do you think?
Yeah, I think
Use geohash.
it would work. Maybe instead of thinking of a database in this particular case, I mean, we have to store the data somewhere, so database is good. But if you are looking for finding active riders to, to get them a delivery, I think we should do it all in memory, if possible.
Okay.
So,
So-
an SQL query, no, we'll just pull up all the riders who are active and keep them all in memory. And whenever a person asks for a delivery executive to a restaurant, we will see in our memory, run through lists, and then pick the best.
Okay, so that does make sense. So we are keeping all the 1 lakh, we'll be basically keeping them in memory itself.
Yeah, per city, we will keep everybody in memory. Maybe we can shard according to city.
Okay, so I have a couple of questions over here. So when we keep updating the location of the driver or of the rider, so basically, suppose we have this as the memory, right? And then we also have it in DB, right? So are we storing the location? Like, how are we going to update it? Like in the DB as well, or are we not going to keep the location in the DB? We are just going to keep updating in the memory.
We should probably just keep updating in the memory, and then eventually we can, like in a asynchronously, we can update the DB when we feel like.
Okay. So
Maybe
basically, this is a write back cache,
Yeah.
right? That we'll be writing in the cache, and then we'll be updating asynchronously in the database. Does that make sense?
Yeah.
Right. So in the DB, but we should discuss, right, that how would we store in which kind of DB. It does make sense over here. What do you think? Which DB?
I would use, because the DB is not going to matter. I would use a SQL database which would just store the delivery person's ID, the location that they currently have, and that's it. That would be one table. Another table would be having all the ratings that people have given to this delivery person, and
Okay.
another would have all the orders in which the delivery person is going to be mentioned. But when we are running the query for matching, we are going to actually do all this in memory. So we will have to take a join on all of this stuff.
Okay. Why do you think different tables for ratings and for rider ID location?
Because they are all separate objects. So order is a separate object in that there's a delivery person. When there's a rating, the rating is given for food, the rating is given for the delivery person by a user. So any kind of query that we fire might be on any of the columns. So I don't want to put it in one place. I want to keep it normalized. And when we are running any match queries, that time, we can process it in memory.
Makes sense. And also, instead of storing exactly the order IDs here, because we have to do the driver matching, we could have like the number of deliveries the person has made in that day, right? In that working day. So that we could store in one of those tables itself. Basically, these are the factors that are going to help us in delivery matching basically. So in our cache, if we think about it, in our cache, what all things do we have? We have the rider ID, the location, the rating, and the basically, what did I just say?
Number of deliveries per day
Number
on
of
that day.
deliveries per day. Does that make sense?
Yes. So the last quantity can be just incremented one by one as they get assigned more and more. Rating, we can calculate it in real time. Only numerator and divider changes. And location, again, is easy to, it is constantly updated.
So here delivery management service has to do a lot of things. So we can say there is a matching service or an engine who is actually talking to the, like, who has the access to this cache and who is actually doing the management for us. And from here, once we get, say, for example, for a particular order, we match, say, 100 riders, we also have to send them the notification, correct? So this is the one who is going to be like sending the notification from there. Does that make sense?
Okay. Yeah. So you have a matching service which is going through this cache.
Yeah. Then there can be basically notification service that is going to basically, so now there can be two types of notifications, where one can be in-app notifications and one can be basically push notifications, right? So if you have to send like push notifications, then we can have basically Apple notification service or other notification services, and we can like basically notify all of these 100 riders, and then one of them have to accept it, and then we are going to assign it.
Yeah.
Yeah. Okay. To summarize till now, the restaurant got the order, accepted the order, then delivery management service has to now manage the entire delivery. Restaurant told the delivery management service. Now the delivery management service basically, first thing that they have to do is matching. So it access the cache, the delivery matching service access the cache, and then ran some algo and basically matched 150 or 100 drivers nearby, which is basically a big number. Maybe in batches, say 10 drivers, then 20 drivers, there will be levels of the algorithm. First level, we are going to say filter out 100 drivers and notify 10 riders. And if one of them accept it, then it is good to go. Otherwise, we're going to notify the next 10. Does that make sense?
Kirti, the 150, like where are we getting that from? If there are 1 lakh riders, and are you dividing the city into small regions? That's how you're getting 150 per restaurant. Yeah. Okay.
So basically per location, right?
Per location.
Like as per the location. Yeah.
Okay. So you're assuming that there will be like, we will break it into such small regions, the city. I mean, around the restaurant, we'll have this geo fence, let's say, where 100, 150 people will be there at most. Okay. Yeah. Makes sense.
Okay. Do you want us to discuss like Quadri again in detail, or I think so they can refer to the Tinder matchmaking video and refer this?
Yeah, if you guys haven't seen Quadri, guys, there's links in the description. You can check it out.
Yep, cool.
It will help you proximity information you can get from there. Okay, yeah.
So this flow makes sense, right? That we have match the drivers, and then we have basically send the notifications, and now they have to accept. And also we have to keep now tracking the drivers. So now I guess we can also talk about tracking a bit.
Yeah, we are making quite a few assumptions here. One of the things is whenever delivery management is going to update this cache for fairness, for the rating of a delivery partner, all of that stuff is happening in the background. Okay, we are not looking into that. They're going to be done through API calls where this cache is consistently updated. Okay, yeah, tracking, I think, Kirti, is where we are now going to look into whether or not there is a delivery going on.
Let's start discussing from why is tracking an interesting problem to solve. Firstly, we have to keep updating the location of the rider in every few seconds, right? Say 2 to 3 seconds. We have to keep updating it. So how do we do that? Now, there are a lot of ways to solve it, like long polling, short polling, WebSockets, SEC. There are multiple things that come into picture when we talk about real-time communication, right? So let's, what do you think is the best bet over here, Gaurav, first of all?
Because we are polling every 2-3 seconds, in my personal experience, I've seen that the rider on the screen, they are in some place, and then 2 or 3 seconds later, they move quite a bit, and then they move quite a bit. So it's unlike Google where you have continuous updates. Here you have like every 3 seconds. So I would think it is a HTTP request. They're polling, long polling probably.
Okay. Long polling, but because it is basically in every 2-3 seconds, you can have a persistent connection, and you can keep like sending the request over the same persistent connection. You can save instead of building the connection again and again. You can use persistent connection, and till the delivery happens, you can keep updating the location like that. What do you think?
Yeah. Persistent connection,
Actually,
but who's going to have the persistent connection? Is it going to be the person who's made the payment or the delivery partner?
it should be delivery partner, right?
Yeah, makes sense.
Actually, not just after assigning, even before it, like basically every time the driver is available for delivery, we should make sure that we have a connection with the driver, and we don't have to keep updating it again and again, because throughout the day, whenever the driver is available for delivery, it is going to be, we have to track its location, right?
Yes.
So it does make sense, right?
Yes.
So as soon as the
absolutely.
driver basically becomes unavailable, we can stop the connection, we can terminate the connection. But whenever the driver is available, we have to make sure that the connection is there.
Yeah.
Yep. Okay. So there's a delivery partner, and the connection is going to be with what service? Gaurav, what do you think?
I think the delivery partner, if they're going to have a connection, it will probably be with delivery management, because delivery management might want to keep that info.
So basically, this same service itself, because I know you hate making a lot of services.
No, but also sometimes it's like totally necessary. So, for example, delivery management service, I don't know whether, what is the delivery management service doing exactly? It's doing a state transition of the delivery. Is it an order management service, something like that?
Yeah, it is like order management service, but here basically, see, the matching part, basically this matching service is doing, right? So rest everything, basically this delivery management service should be doing. Should it be keeping tracks of all the delivery partners?
I think then it should be some other place, like maybe delivery partner where they are, should maybe, if you put
Based
it in
on
delivery
your
matching
reaction,
service.
if you think, should I just remove this delivery management service and directly, like the restaurant should be talking to the delivery matching service?
The problem with that is, a restaurant says, hey, I've accepted the order. Then they say, okay, I'm ready with the order. So maybe a service should be in between. Whether we put two services together is the thing, but I think they can be separate, because this has totally different logic. Delivery partner though, maybe we can send them to delivery management, delivery matching service directly. The one that you have.
Okay.
Yeah.
Okay, got it. To basically to this service, so they can also directly keep updating the cache.
Yeah.
So here we are going to have our persistent connection.
Yeah. So we can increase the size. There's a 14.
Yeah, I'll do it. Making sense, right?
Yeah. This is good. This is clear that delivery partners only talk to the delivery matching service, and the reason for that is because the only people who are interested in where the delivery partner is right now is mostly delivery matching. Okay, and
correct.
When a person wants to see where a partner is, all they have to do is they have to ask maybe the matching service, or you can call it, this thing can be called a rider matching or a rider management service. Actually, instead of delivery matching service, we can call it rider management.
So this you want rider matching service. Cool.
Okay, this is better, no? Thoda color aa gaya.
So Gaurav has made our diagram more clean, more colorful and clear. Cool.
One thing I'll just do here is I'll just rename this to rider management service, or I'll just call it rider manager. Now, apart from this, the one thing which is super important during tracking is location. So the delivery partner is sending consistently their location to the rider manager. I'll just call this rider. And the person wants to know where the rider is right now. So where is the rider? This can be considered as a API call. I'll just increase that. Okay, so now let's describe the API in a minute. But if the API can pull the location, then the person can see where they are. So the rider and the person will be happy. So let's increase the size. In this get rider location, and the thing is, the client, the mobile client may not know where the user is. So I have a user ID, and I may have an order ID also. I think I will. And what I'm expecting as a response is, I expect a rider location. So
this again has to happen in every 2-3 seconds from when the delivery partner is assigned till the delivery is complete. Correct?
Yeah.
So in that duration also, do you think there should be a persistent connection? Because this has to happen in every 2 to 3 seconds.
No, I don't think so. There's no need of creating a connection. Every 2-3 seconds we are polling. People don't watch the entire delivery. They just see it for a few seconds and then they're gone. So creating a WebSocket connection is not something I will do. I'll just fire a request. Most of them will drop off in 2 seconds or 3 seconds after watching. So HTTP request, yeah.
Okay, so basically whenever the person opens the map, only then this API will be called. Otherwise, you're not going to have the basically long polling or WebSocket. None of that you're going to use, right?
Yeah, this rider location will be cached. I'll do that by having a cache of rider ID to location. And then we have rating and number of deliveries. So this part is already taken care of. This was the key for the cache. So I get the location, and this I can.
What you said does make sense. I'm sorry. What you said does make sense for that if the user opens and then closes, right? But do you think on the client side there should be like a check that if the user has continuously left it open, then don't you think it is a lot of load that in every 2-3 seconds you're sending a network call and establishing a new connection?
No, all of this stuff is cached. Every 2-3 seconds you're sending a network call is fine. If you wanted constant updates like a chat connection or something, I would understand. But okay, now there can be 2 approaches to this. One is if you see that the person has constantly kept the mobile open and you want to send them in a different route, that okay, this person wants to see the entire delivery, so let's create a connection for them so it's more efficient. We can do that. I probably wouldn't, because 99% of the people are not going to be tracking the delivery partners throughout. So we can, I'm making an assumption here. If I see that the data is more on, everybody sits and watches the delivery partner till they reach home, then yes, we will create that. We'll make connections default then. Or if we see a significant amount of, time is taken just through HTTP requests, then also we can change. Yeah.
Right. Interesting. Okay, got it.
Yeah. Okay. So we have tracking then solved. Basically, a person is asking where the rider is through this API call and getting it immediately. Matching, Kirti, I think you already described really well. Restaurants tell a delivery manager, who then inform a rider manager that, get me the best riders for this order. Get riders for an order. Basically, the order contains the restaurant location also. Based on the restaurant location and the number of deliveries that day and everything else, we select the best delivery person, assign them to this order, and now they can be tracked. We haven't spoken about ETA, we haven't spoken about routing. The main reason for that is we can assume that that's being taken care of by some other service. So let's say there's a routing service which people can connect with. So maybe the rider can connect to a routing service and get the best route. So we are actually done with rider tracking and matching. This is a super specific discussion. I think we didn't get into any of the complementary or auxiliary features that we could have gotten into. It keeps things focused. Very often in an interview also you're asked to build one part of the system. You're not asked to build the entire system. We focused on just delivery, right? Not order management, not creating profiles, not inventory, just delivery for a large scale distributed system like Zepto or Swiggy or Zomato or even Amazon. In that, we focused on just one thing, which is partner tracking and matching. We did not focus on, if there's a customer support issue or if there are other issues which come up, like for example, the route has too much traffic. No, we didn't focus on that. We didn't focus on setting alarms that your partner will be delayed and all of that stuff. This helps talk about the exact thing that either your team wants to talk about or the interviewer wants to talk about, right? It's always fun to talk about all the things that we know, but to pick the problem and pick a specific part of the problem, that is more interesting. I think it's also easily shareable for you with your friends. Guys, if you're watching this and your friends are looking for specific system design videos, this series is built around that. We talk about one specific problem and we solve it. So thanks for tuning in, and we'll see you next time. Bye-bye.
Thank you so much.